Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Tamaki Makaurau, Auckland in New Zealand.
And I'm Zack Semke, coming to you from Seattle, Washington.
How's it going, Zack?
I am doing great. How about you?
Pretty good. You've had Thanksgiving since we last spoke.
Indeed. And we're all hurtling toward the winter break as well.
Winter break for you, summer break for me.
I know.
Everything's
That's right.
kind of sort of winding down. Well, there's a little bit of activity going on out there, but I think pretty generally people are sort of looking forward to a bit of a break and saying farewell to 2024, moving on. But we've got I really enjoyed this interview that you did with Chris Magwood this week. So I'm really excited to get into that. So we should do that. But before we do, we've got a few people to thank.
Indeed. So we have a couple of special thank yous for this week. Our accelerator partner of the week is MP Boston. MP Boston is the developer behind the Millennium Tower, the incredibly exciting and big building, Passive House building in Boston. And our sponsor of the week is Rockwool North America. And Rockwool, of course, provides exterior insulation and interior insulation to all sorts of buildings, including very big ones. So it's kind of cool to have them both as special sponsors this week in making our programming possible. I also want to thank our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool North America, and Zola Windows. And thanks to our champion sponsors, Bowizo, Icon Windows and Doors, Intelligent Membranes, and Source 2050.
All right, Zack, how did you come to be having a chat with Chris Magwood?
Well, I have been following Chris's work for probably a decade, maybe more. A lot of us in the North American Passive House community, I think we're first introduced to the concept of embodied carbon and its importance probably through Chris Magwood. Certainly, and as you'll hear in the interview, the concept of embodied energy had already been floating around, and a part of conversations. I remember Dylan Lamar speaking about embodied energy at a Passive House conference in Portland, Oregon, 2011 probably. But this notion of embodied carbon, of upfront carbon, was just, Chris has done so much work to understand embodied carbon and upfront carbon, and we'll get into kind of the definitions there in the conversation, and find strategies for addressing this source of carbon emissions and even looking at sequestering carbon in building materials. And that was the topic of the Biomaterials conference, the Reimagine Biomaterials conference that happened earlier this month, which was fantastic. Chris approached us several months ago with the concept of doing that conference in partnership between Passive House Accelerator and RMI. And so we've been working closely with Chris to curate that conference and to produce it. So it was just a pleasure to have a chance to sit down and have some dedicated time with Chris to ask him about his journey to all of this work and what lies in store moving forward. So I hope everyone enjoys it.
So let's get into it.
Welcome, Chris Magwood, to the Passive House podcast.
Yeah, so glad to be here.
Yeah, I am incredibly excited about this. This is coming off of the heels of the Reimagine Buildings Biomaterials Conference earlier this month. And I can't wait to dive a little deeper with you here during this conversation. Maybe we could start by having you just introduce yourself and the work that you do.
Sure. Yeah. I guess my background is in the design build world. So for about 25 years, I ran a small design build company here in Ontario, Canada. For the last 15 of those years, the design build firm morphed into a design build school called the Endeavor Center. So, we kept designing and building buildings, but using them as opportunities to sort of train students. So people would come and join us for the length of one whole build. So they would see a project from start to finish. And so that practice was, really focused on all the kind of ideals of green building as they've, developed over that 25 years. And so, energy efficiency, renewable energy, zero carbon kind of goals, but also material health, resource efficiency. We tried to consider all of those things. And I mean, what people kind of know me for now is the work in embodied carbon, which really just came out of a question my daughter asked me actually at at that time she was a teen and experiencing some, pretty real climate angst. It was like 2011, 2012. And she really kind of came to me and said, Dad, are you doing something for the climate? Because I'm really worried. And, I know you do this green building thing, but does that help? Are you part of trying to do something? And so I felt, I could answer her very clearly on the one side that, by that time we were doing, highly efficient buildings, all on renewables, like very clearly zero carbon on that side. But it had been gnawing at me a little bit that I didn't understand the materials. The notion of embodied energy had kind of been starting to enter the discussion at that point.
Right.
And so I thought, well, this is my cue to kind of dive in and, I should know for these buildings that we're doing with the school, I should understand the carbon footprint of them. And that meant that I started looking for that information pretty early on in its development. So there wasn't a lot out there. I thought I'd spend a few afternoons, gather some data, have an answer, and move on. But, because I was interested in that gap and the gap was there, I kind of decided to dive in and help fill that gap. So, out of all of that, I sent myself back to school. I did a master's that allowed me to do a project that ended up being the basis of the BEAM tool. I wanted to look at the carbon footprint of a couple buildings. And in order to do that, I needed to figure out a way to do that. And so I kind of built a spreadsheet that enabled me to do that. And when I started presenting the results of my thesis, people were like, yeah, that's cool, but what tool did you use to do that? And so, there was just a lot of interest in a tool specifically for the kind of residential sector at that point. The reason I built my own tool was that I tried to use the existing ones, EC3 and Tally and One-Click LCA and Athena, all great tools, but really not designed for the residential market. There were big gaps. Lots of the really common product types in residential construction didn't exist in those tools. You couldn't default to certain assemblies. Like it would, I realized early on, I'm not going to be able to use these things to model this type of building. So got involved in, sort of making my own tool, and that's kind of been my work ever since, both with Builders for Climate Action and now with RMI, kind of working on embodied carbon specific to the kind of residential sector.
Yeah, it's a really great and inspiring and important journey that you've been on for the last dozen years or so. And of course, and then many years before that. You mentioned the embodied energy, and I remember back probably 2011, 2010 becoming aware of that notion of embodied energy. When did that switch, or how did that transformation from conceiving of it as embodied energy to conceiving of it as embodied carbon happened? Do you remember that as like a switch
Yeah.
that flew that what is the term? What do you do with a switch? You flip it?
Flip a switch. Yeah.
You flip a switch?
Yeah, I think, it was for me seeing one of the original databases that had this information in it was the Inventory of Carbon and Energy, which came out of University of Bath in around 2010. And they were giving answers in embodied energy and in embodied carbon. And at first, I was looking at the embodied energy side. That's what I was interested in. And then I was like, oh, like what is this number? And why is it so wildly different for some things? Like some products that had very low embodied energy had these really concrete in particular. It's like, wow, if I look in column A, concrete looks great, very low embodied energy material. If I look in column B, the embodied carbon is massive. And that, I think a lot of people had that moment where it's like, oh, energy, it depends where are you getting the energy. Like, I can have energy embodied in a product, and if it's all renewables, in some ways it doesn't matter to the climate how big that number is. What matters to the climate is the embodied carbon piece. And that's where you start to see that materials like, foam insulations and concrete, not only do they have quite a bit of energy and the emissions associated with them, but they also emit greenhouse gases, as part of the sort of chemical process that happens. And so, especially because I was going down that path to kind of answer this question, am I doing anything for the climate, from my daughter's perspective, then it was like, oh, this is the number I should be looking for. And I kind of, turned my attention from the embodied energy to the embodied carbon. And I think that happened for a lot of people. Like the impetus to research this was the climate. And, it became clear that, oh, this is the metric that matters when you're thinking about that.
Yeah. Yeah, that makes a lot of sense. Now, also in your description of the journey that you've been on, you didn't mention the books that you've written. So maybe
there's been a bunch of those. Yeah.
Could you just do, like, what if somebody if the listener is curious about diving into learn more about your work in that regard, where should they start?
Yeah, I was the editor for a series with New Society Publishers that I think it capped at like 15 or 16 titles. So it's a pretty big library. And sort of each book was about started being sort of a material approach. So, there's an essential hempcrete construction, an essential straw bale construction, cob construction, focused on that. And then we branched into mechanical systems. There's one on sort of, rainwater, one on composting toilets, those sorts of topics. But two in that series that I still use and I think are still really valuable more broadly is Jacob Rakusin wrote a essential building science book in that series. And I wrote one on sort of sustainable building design, which is, basically it was a book version of the course that we were teaching at Endeavor, where we were trying to show our students that green building, or whatever you want to, whatever name you want to put on it, sustainable building, isn't a monolithic term. And, we had sort of realized in working with clients that for some people that meant energy efficiency, for some people that meant indoor air quality, for some people that meant resource efficiency. Like there was all these sort of different aspects to it, cost and affordability, all of those things. And that the solutions to coming up with the best building involve understanding like which of those criteria matter and in what order do they matter.
Right.
And you design a very different building if the leading concerns are indoor environment quality and cost than you do if it's energy efficiency and waste, or whatever the sort of arrangement of criteria are. And so that book is sort of built around, it has a criteria matrix involved in it. Like how can you think about these things, and what can you use to sort of rate success or different levels in all of those different criteria. And so, yeah, that's a book that, it's well flipped and worn on my shelf. And I still hear from lots of people that they find it really useful.
Excellent. Excellent. Thank you. Thank you for that. So let's maybe swivel to a little bit more around the definition of embodied carbon. So another term that Lloyd Alter has, I think, been popularizing is upfront carbon,
Yeah.
which I think has a lot of kind of explanatory power. Perhaps
Mhm.
isn't completely as encompassing as embodied carbon. So could you kind of dive into that a little bit?
Yeah, I would love to. I mean, very early on in my work on embodied carbon, I showed up at the very first Carbon Leadership Forum meetings when it was just, a handful of people, and I kind of said, I think this term we're using is not good. Like, we're not actually, if you hear the word embodied carbon, you think, oh, it's the carbon in a thing. Like when you embody something,
Right.
it's in it. And it's like, no, that's not what we're talking about.
Yeah.
Later, we'll talk about carbon in things, but that's not embodied carbon. Embodied carbon is like these emissions that happen from the process. So I think, Lloyd and I talked quite a bit about, upfront carbon and various ways of explaining it. I think at that point, enough academics had put enough papers out and search terms and stuff around embodied carbon that it held as the term, even though I think it's done, quite a disservice. We all have to spend a whole bunch of time explaining what it is and isn't, because it's
that
not.
sounds so much like passive house as a term. It's like so many parallels there. Yeah.
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 Yeah. But, it is kind of the term, but I think, broadly embodied carbon is the emissions associated with either at the product level or at a whole building level with the entire life cycle. So, from the minute a raw material is kind of, harvested somewhere to, when it finds its way into a landfill or gets incinerated or gets recycled, it's sort of all of those emissions. I think Lloyd's focus on upfront kind of matches mine to a big degree, because really that's where most of those emissions live is in the kind of product stage, or like, getting that thing into a building is where the bulk of the emissions happen. And those are the emissions that we can measure, like you can measure what has happened. The rest in embodied carbon is sort of these projections. What might happen?
Sure.
When might that get replaced? What might it get replaced with? What might happen to the thing? It becomes not less important, but way more difficult to quantify, and also often, especially in the home builder realm, falls well outside of the kind of realm of responsibility that builders sort of have typically had for their buildings. Like, yes, you choose the things that go into it and how they got there and how it got assembled, but you don't choose when the flooring gets replaced. You don't choose when the cladding gets replaced. You don't decide where it goes, when it's taken off. So I think a lot of the focus, the really helpful part of the focus, is on that upfront piece, because when you're talking to people in the building community, that's what we can affect, really. And we can make good choices now to make sure the worst things don't happen in the future. But we also can't guarantee that. Like, you can fill your building with easy to recycle products. Doesn't mean the homeowner's not going to send them to the landfill,
Right.
Or vice versa. You put a product in that can't be recycled today, but when it's taken out of the house 50 years from now, that does happen. So, just a lot more uncertainty. So, yeah, I've definitely been focusing my work on that. What's the lever we can really, pull on as people in the home building sector? It's the upfront piece, because those are our decisions, and we can measure those. And the stuff that happens later is I never want to be dismissing it as not important, but it is a smaller piece of the emissions pie, and it's the piece that we can only guess at. So.
That makes sense. You also alluded to this, the kind of misperception that people have around the term embodied carbon, that it leads people to think about the carbon in materials, and that. So let's talk about that, because that's where
because that's the exciting part. Like, that's
exactly
the part that got me. When I was first diving into embodied carbon, the idea that, oh, like in my own practice, I did a lot of straw bale construction. I used, materials like hempcrete and, lots of timber and stuff like that. It hadn't occurred to me that, oh, there's a climate benefit to carbon in things that, was otherwise going to go to the atmosphere, and you put it in a building. And so that I didn't go into researching embodied carbon with that in mind. That some of the early, that ICE database, had a line in it for straw, and it had a negative number. And I actually called the folks at the University of Bath. I was like, what is this? Like, how does something have negative emissions? And that's, even though I was somebody using that material, like it took somebody explaining that to me, like, oh, I get it. Like, yes, there are emissions involved in producing this into something that goes into a building, but the amount of carbon that came out of the atmosphere, for plants by photosynthesis, if there's more that came out of the atmosphere than went into the atmosphere in getting that product into the building, then there is sort of like a net negative effect. And as I saw that, I was like, oh, this is this is really interesting to me as somebody using that material, but also it sort of, in a lot of ways, embodied carbon can be really depressing to study, because we can see ways that you can reduce this much percent and that much percent, and maybe you can get a house down 30-40% less, and that's great and worth doing. But on the operational carbon side, when you start putting renewables into the picture, it's like, oh, like this is how we offset those impacts, or like this is actually how we get to zero. And then seeing that potential in biomaterials for the carbon stored in things, is like, oh, this is the renewable energy piece for the materials side. Like this is how we actually can do potentially zero carbon buildings on the materials side, in the same way that, I mean, you can do passive house, but if you're on fossil fuels or on a grid that uses fossil fuels, like there is no zero. The zero comes from having this the ability to sort of swing things the other direction. In the case of the energy side, the operational side, it's putting clean energy onto the grid or using it directly in the building. And on the material side, it's like carbon storage in the materials is what allows us to get to zero. And then that, to me, was exciting. And I would much rather be working on something where I can see like a complete solution, like, oh, we can get to zero on this, than like, oh, we can work really hard and make a 40% reduction.
Do somewhat less harm. Yeah. And that's a big shift emotionally, and also a big shift for the planet potentially, if we can if we can scale that up and figure out how to do that. So, and in your writing, you also distinguish between materials. So biomaterials are a big piece of this this story, and you distinguish between different kinds of biomaterials, and say like straw versus wood. Could you talk a little bit about what makes those two categories so different?
Yeah, I mean, I think it's really thinking about that feedstock that might go into a building. What was destined to happen to it if it didn't end up in a building? And so for products like agricultural residues, for things like the old newspapers that go into cellulose insulation, if those things don't end up in buildings, they end up in landfills or incineration, or in the case of ag residues, being burned off or rotted in the field. But kind of regardless of what actually happens, that carbon is going back to the atmosphere. So in that case, kind of rescuing it, making sure it doesn't go into the atmosphere and putting it in a building has a sort of calculable and immediate effect on the climate. When you think about virgin timber, people always like, one of the first things I get is, well, that has carbon in it too. It's 50% carbon by weight. And it's like, yeah, it's not, nobody's debating the actual carbon content of that. But the counterfactual is, if I didn't put that tree in my building, it would be a tree.
Right.
And if it was a tree, it would continue to draw CO2 out of the atmosphere for the rest of its life, which would be a lot longer than when I cut it down. So there's that piece, like we're actually interrupting the lifespan of a carbon sink. And then when we actually do cut down the tree, we leave the root ball in the ground. So, 20 odd % of the carbon embodied in that tree stays in the ground and rots and goes to the atmosphere. And then of the wood that's removed, and we also leave all the branches and slash and, stuff in the forest. So by the time, I put the 2x4 in my wall, maybe that represents half the volume of the tree. And I think, that number depends a lot on forestry practices and what happens to certain residue paths. But in general, it's around that. And if it took, say there was 10 tons of carbon in that tree, if I had to send 5 tons into the atmosphere to put the other 5 tons in my building, have I done anything for the climate?
Right.
Doubtlessly, there are 5 tons of carbon atoms in my building, but did the climate experience that as a benefit? And I wouldn't say the answer to that is categorically no, but I think it's like nobody really knows, and it's a complex thing to figure out, but I wouldn't want to count on it. Like if I'm trying to save the climate, that pathway, and again, like I'm not a wood is not good person. I mean,
sure.
Wood is essential to the construction industry, and from a carbon emissions point of view, it's a low carbon option, and it's featured in all of my buildings and will continue to feature in homes a lot. But as a help the climate strategy, to me, it's not a proven version of that. And a lot more work needs to be done to go, okay, if we count all of that, like if we don't just count the carbon atoms in the 2x4, if we sort of count what went to the atmosphere across that entire process. And that's without even getting into the question of what comes out of the soil when you start harvesting trees from forests. But even if we don't go there, just that, from the sheer volume of carbon in the tree, we know that only a percentage of it makes it into a building product, and that doesn't add up to necessarily climate savings. That said, one of my colleagues at RMI is doing great work looking at the thinnings that come out of forests right now. The U.S. Forest Service spends about $4 billion taking trees out of forests to reduce, fuel load for fires and things like that. Right now, nothing happens to that wood. It goes back to the atmosphere. So I would say, if you're making a product that goes into a building out of thinnings, I would count that as carbon storage, because again, if we didn't put it in a building, its fate was to go back to the atmosphere. But if I look at a virgin forest stand and I think, well, what if I don't put that wood in my building? The answer is it doesn't go back to the atmosphere. It contributes to sort of like a robust, ecosystem that is one of the key carbon sinks of our planet. And so, I think there's a big difference between those options. Like what the essential question you want to ask yourself is, what was going to happen to this material? Like if I didn't put it in a building, where was it going? And, I think that whole category of products, from ag residues to, waste stream things, and there's lots that we don't even look at now. The amount of clothing like that goes to landfill that could be insulation or turned into other products. There's all these things that we know, this is going back to the atmosphere. Virgin wood is not one of those things. And so I think that's, to me, where that difference lies.
Yeah, no, it's a great explanation. It feels like a microcosm of some of the same thinking that goes into trying to puzzle out carbon credits.
Yeah.
It's like, basically is that question is what will happen? What's the counterfactual if you know, if so, really interesting and also complex. And I think the other thing that highlights is just like whenever we start talking about carbon, we emit systems thinking is just so incredibly important. As soon as we lose sight of the bigger picture of how things operate and how ecosystems work and what how does the system of producing lumber work, if we lose sight of that, then we can come to some kind of misguided decisions potentially.
Yeah. Anytime you're sort of reducing it to like a carbon ledger, because even the sort of ag crop side of things, I think to me there's a big difference between the residues that happen from existing food crops versus like a plant that we decide, oh, we should plant this so it becomes a building material. Like, again, there's a big difference.
Yeah.
One is we're growing that food regardless of what happens to the residue. We're going to grow wheat and oats and rice and, all of those things. And those residues are always going to accompany that and in pretty big volumes. But if we are, planting elephant grass or hemp or something that doesn't currently, encompass a lot of acres, I wouldn't say we shouldn't do that, but we should think, well, where are those acres coming from, and what's the land use change that's sort of underpinning that? If it's, oh, we're rotating this in with other crops to help soil health, great, or if we're taking, I know like there's lots of farmland, what Planted is doing with elephant grass is on old tobacco farms. And it's like, okay, that farmland had ceased being active. It wasn't growing food. It never grew food. It grew tobacco. That seems like an entirely reasonable place to put a building crop. But do we want to cut down a forest to plant a building crop? Right. No. Do we want to displace, really important food crops to grow building crops? No. So I think, it's always more nuanced than just, oh, look, I can attach a negative carbon number to this, therefore, like, it's great.
Right. So you mentioned soil health, and I imagine you get this question a lot about the soil health of these croplands when we're taking away some of that residue that would otherwise somehow some of that carbon or nutrients from that could, I imagine, would typically go back into the soil. Is that how do you think about that, and what is there a how does that factor into
the I think,
picture?
At that point you start getting into very specific, like what is the crop and what happens with that thing now. I think because I know the world of grain straw pretty well as a builder using that resource. I know from talking to farmers that they don't tend to turn a lot of that into the soil, and this is like an interesting rebuttal to the doesn't that stuff just rot if you put it in your building? The reason farmers don't turn it all back into the soil is because it doesn't break down very well in the soil, and it leaves like a tangled mess that like you literally, if you just tried to fold all the straw back into the soil, you would just like straw in the
creating some weird concrete.
So we know that for that crop, only a certain percentage of it is ever going to get turned back into the soil. Like that's the the reason it gets removed is because it doesn't work to put it back in. That's not true of every crop, and I think as we start to explore that kind of intersection between agriculture and buildings, which is just in its infancy now, I think it's going to be important to ask those questions to sort of understand is there enough of this residue, what are its other potential uses. I think when I look broadly, I think, oh, I can see that we grow more than enough straw in the United States that you could replace every product that straw could be used for. So insulation, wall boards, like all the things that straw has been made into in every house in the US, and not be touching like half of what's grown in a year. So, there's lots of it. But when I look at that, I think, well, the reason there's lots of it is because we monocrop that stuff in really unhealthy ways. And so, that's also not really a sustainable thing to do. But in one way or another, we feed ourselves and we're going to grow things to feed ourselves. And there's always going to be residues involved with that. And, on a region by region and a crop by crop basis, I think we're always going to find, oh, there is a lot of this left over, and we could make an awful lot of building products before we, start hitting that point where we need to, make sure we're not doing the wrong thing as we're trying to do the right thing. But we're, I think we're very, very, very far from that. And we never reach that threshold with some of those residues.
That's really helpful. And also, with that kind of transformation of the way that we grow food, as we get to that place, I imagine that we will have evolved somewhat in our thinking about our relationship to the earth, and maybe we'll be more willing to embrace all sorts of earth-friendly.
I mean, there's a great future state where, we're farming in a regenerative way where carbon is actually going back into the soil and being stored there.
Right.
And we're able to take some of that residue off the field and put it in buildings, and we're kind of getting a 2-for-1, or, it might even be as much as a 3-for-1 when it comes to kind of, soil storage. So I think that's, the place to be aiming for, is not just, oh, great, there's all this stuff that we can go get and it's, it's good. But if we can sort of aim to reach the best possible state with that, we can actually be doing even more good instead of just kind of cleaning up the mess of industrial agriculture.
Right. So my next question, it was going to be about, is zero carbon building, like actual operational and embodied carbon, zero carbon building, possible? I think that what you're saying is yes. And
I would say maybe, yes, I'll put big air quotes around the yes.
But it's hard. Yeah. And so like, I remember just a couple of years ago, I was at one of the International Passive House conferences, and there was a presentation by a Swedish architect who was trying to achieve zero carbon, and all the innovations that she applied to make that happen was really inspiring. And it didn't get to zero carbon. It's not an easy task. So where do you feel like things are at with that, and what's the kind of the prospects for getting there?
I mean, I think, right now, any notion of zero has the word net before it, and that's true when I'm, talking about the negative numbers for biomaterials. Like, we have modeled some buildings that, if you factor in the stored carbon, and, if you only focus on the stored carbon that was going to go back to the atmosphere, that are sort of at net zero, slightly better than, like somewhere in that range, but it's a net, like, emissions still happened, you just happen to have stored a carbon equivalent, but it's, and I think that's a laudable goal, and really all we can achieve right now, because I can't snap my fingers and the entire economy is carbon free, so
exactly.
The things that I'm going to put in my buildings, the glass in my windows, and the nails, and there's a lot of things that we're quite some time away, maybe never going to get there, of those things coming with no initial carbon footprint price to them. But, the fact that we can get a building to net zero now is great, and like totally the right thing to do. And only, as the carbon intensity of the whole economy decreases, that storage becomes like more and more valuable and important. But, like right now, sort of all we can do is net it out. Same way with energy, like unless you're literally living with, the direct solar energy that you can capture.
Yeah, no kidding. Right.
It's, there was an emissions price for your PV panels and, all those other things. It's just, you can do the math to net it out. And I don't, there's a lot of people like, oh, if it's net zero, you haven't really done anything. It's like, no, you've done the absolute most that you can do in an economy where we've built the whole thing on emissions being part of, the scenario. And I think the efforts that we're doing now to get to net zero if and when the economy decarbonizes, get even better. But that's, in terms of where you can aim right now, you can aim there and you can get there. So that's what we need to be doing.
Right. And I guess just going back to earlier in our conversation, should emphasize that we're talking about the early stage of the building. We're not necessarily addressing what happens. Although I know that you are in some of your work working addressing circularity. So as, say, the listeners, taking this in, and I imagine like a solo practitioner, or who's already kind of overwhelmed by all of the tools and planning and potentially modeling that goes into a project, and then thinking about taking on the upfront carbon implications, the carbon sequestration potential of their projects, and maybe feeling a little overwhelmed. What are some of the key moves that they should be thinking about to reduce embodied carbon or even sequester carbon in their project?
Yeah, I guess, my first thing would be to say, especially on the embodied side, don't be scared of the tools. They're not that difficult to use. And I think especially something like Beam, I'm always kind of letting builders know, you don't even have to model your whole building. Like, don't get to that level of complexity. Open up the tool. It's built to be comparative. You get to the exterior walls sheet, and there's every insulation product that there's data for. You can scroll it and go, oh, that's a high emitting product, that's a low emitting product. You don't have to go any further than that. You don't have to build a model. You can just be like, oh, that's a better choice than that. So I think there's that, just getting familiar with that. And the nice part is, like, doesn't matter what the amount of it you're using, it always scales. If material A is 30% less emissions than material B, no matter how much of it you put in your house, that 30% always exists. Like, it doesn't matter if you're building a 10,000 units or 1 unit.
Right.
If you make that choice, that 30% holds for any amount of material. So I think just understanding, becoming a bit familiar with what those things look like. But all of our studies show that the concrete, the insulation, and the cladding are typically 60 to 75% of the embodied carbon of the whole building. Like, those 3 material categories, if you can address those, you've done the heavy lifting.
Right.
That's not to say, like, you could actually exceed the amount that you could make a difference there by paying attention to, like, all the things, the drywall and the ceiling and the flooring and the paint and all of those things. But that gets complicated. Like, then if you want to address your concrete, use as little of it as possible and talk to your supplier about getting the lowest carbon version of it as possible. Lots of builders don't know that your ready mix supplier can mix up a whole bunch of different, formulas, some of which have 40%, 50% less carbon footprint than their typical one.
Yeah.
If you just say, send me a load of 25 MPa concrete, they're going to send you the normal one because you didn't ask for the low carbon one. But in a lot of cases, and more now, it used to just be only in big cities could you get that, but now it's pretty well distributed. That sort of some versions of the low carbon concrete are available everywhere. So if you can use less and use the better version of it, like, that's again, you don't need to necessarily know the number, like the actual difference you've made. That does make a difference. With cladding, if you scan the list of carbon footprints for cladding materials, you will see that brick, whether it's clay brick or cement brick, is by far the highest emitting option. And there's a whole bunch of things, that are lower than that. And so, thinking about, whether that's the product that you absolutely need to install. And if you do, can you be using like thin face bricks instead of full depth bricks? Because again, if you can use a third less of the material to achieve the same look, then you've used a third less embodied carbon. And then same with insulation products. If you scan the list, you'll see that the foams are at the high end of the list, and the sort of mineral products are in the middle, and the bio-based ones are, at the low end. And, anything you can do to kind of like move to the lower end, whether it's within the same product category, like, oh, I use fiberglass bat, the best manufacturer right now has 40% less carbon footprint than the worst one. You don't have to even stop using fiberglass. You could reduce 40% of your emissions by choosing, the best available brand, or you could go, oh, like cellulose, the carbon footprint is way lower than,
right.
So I'm going to choose that. So I think just, honestly, just familiarizing yourself with what the kind of carbon footprint of those products is. And it's easy to do because, a tool like Beam is free, and all you have to do is scroll it. You don't have to get into in-depth modeling or, super accurate. I have a version of Beam where I just have 100 square feet in every dimension column. And then I can go to any product and go, this is the carbon footprint of 100 square feet of this,
Right. And
then it doesn't matter whether I'm using 3,000 square feet of it or 2 square feet of it, the relative answer is still the same. So
yeah.
It's getting pretty easy to understand that now.
That's really helpful, and I think demystifies or makes it less scary, way less scary. And you mentioned the best fiberglass. So who makes the best fiberglass?
Oh, I'm not gonna say that.
Oh, okay, all right, fine, fine. That's very diplomatic of you. I appreciate that. This is so. Why don't we? I know that I probably don't have much of your time left. I appreciate the time that we've had together already. Before we close up, though, I'd love to dive a little bit more into the Beam tool and how people can access it. Are there kind of, I know that you have a pretty in-depth course as well to probably learn how to actually model a full house. Are there intro courses as well? Like, how can people dive in?
I would say, the Builders for Climate Action website sort of lists all the courses. It's where you can go and get the tool. I say the tool is free, and it is, Builders for Climate Action doesn't charge. However, all the development work that goes into the tool is from people who contribute as they use the tool. So, if you use the tool and find it's helpful, it's basically a user-funded tool. So we wanted it to be free so that everybody had access to it. But, we're also hoping that if people find it valuable, they will, return some of that value and help the tool keep developing. I will say that just this week, this past year, I've been working with the ResNet organization. I've been chairing a standard development committee so that we've basically developed a standard ResNet 1550 for the measurement and reporting of embodied carbon. So, I think one of the things that's made this field sort of difficult to navigate is, you get the response of like, oh, you always get a different answer no matter what, however you model embodied carbon, you always come up with something different. So is it sort of useful? And I would say, it's as useful as the car mileage sticker that you have on a car. Like what ResNet 1550 does is prescribe a way that you do this so that no matter who's doing it, you get, comparable answers in the same way that, if you did fuel mileage on cars by putting your foot flat to the floor and driving down a straight highway until you ran out of gas, you'd get a very different number than if you puttered around town slowly. So fuel mileage numbers come from a standard that says you have to drive the car for this long at these speeds in these conditions, so that you get a comparable number. And I think, ResNet, the 1550 standard will sort of do that. It'll be like, oh, okay, now anybody following this standard, the answer you get should be comparable to the answer somebody else gets because we're doing the counting in the same way. And so that's out for public comment now. So I would encourage people, it's open till mid-January to go read the standard, see what it looks like. And, now is a great time to sort of have your say in that. And that was a long way of saying that, Beam will adjust itself to kind of become compliant with ResNet 1550. So for a little bit, there's going to be a standard and potentially no software to do the standard in, but as possible, Beam will try to catch up and make sure that there's now a tool to accompany that standard.
Amazing. Well, look at what you got yourself into when you decided that you would spend a couple hours in the afternoon to
Yeah.
puzzle through embodied
It was
carbon.
like a little side project off the side of my desk. Yeah.
Now developing ResNet standards and all
Yeah.
sorts of amazing things. Chris, I'm just so glad that you're doing the work that you're doing, and so grateful for it. And it would have been very excited to have a chance to do this interview. So really just appreciative of the contributions you're making.
Yeah, and I feel similarly. I feel like, and that the ResNet Standard Committee was a great version of this, but just, how many people are interested, how many people are kind
Mm-hmm.
of coming together. Those standards are very like voluntary efforts, people
Sure.
putting time and effort, everything that, the whole Passive House Accelerator team is doing. I just feel like there's this really exciting kind of groundswell of effort. Some people have been doing it a long time, some people a short time, but it really does feel like there's a lot of movement here, and it's lots of people kind of contributing a lot of effort to making all of that happen.
Yeah. Well, yeah, I feel the same way. So onward and upward.
Yeah.
Well, thank you so much, Chris, and we'll talk soon.
Yeah, absolutely. My pleasure.
Well, that was Chris Magwood, and you can find him and more about all his great work at Chris Magwood, including some of the books which you reference in there. Is quite humble about those, Zach.
Yeah.
So I'm very pleased you brought those up. And I want to mention BEAM. A lot of people will be familiar with BEAM, but that is the Building Emissions Accounting for Materials, so BEAM. And you can find that resource at buildersforclimateaction.org. Just all one word, buildersforclimateaction.org. And I believe it's free, Zach.
It is. That's right. And also, I know that they accept donations to help the development of the tool as well. But yeah, you can download it for free.
I love hearing about those stories of something that starts as a research project and ends up becoming somebody develops the tool that they want to use, and then realize that a whole bunch of other people might actually also want to use something similar.
Yeah.
So
no kidding.
Yeah. And great to have people like Chris smart enough to put that together, but also great, nice enough to share it with the world and put it out there. So really, really cool stuff. And of course, we talked about embodied energy. Lloyd has talked about this. He mentioned Lloyd Alter, the conversations that he's had with other people in the industry, this distinction between, there's a few terms there, embodied energy, transitioning to embodied carbon, and then your discussion around that it's more correct or a better way of thinking about it is upfront carbon, because we're not always and just talking about the carbon that's locked into the material itself, but also the energy or the carbon emitted in the production of that product from its raw materials. So there's lots of things in there, and as you point out, that it's kind of another example of the term that's kind of become established, not necessarily being the best term to describe.
Yeah, it's really kind of hilarious. Yeah. It's like, why do we do this to ourselves?
Yeah. I mentioned Lloyd because he is on a bit of a campaign to try. I don't know if the tide's already turned, the horses bolted on that one, but yeah, he advocates for using upfront carbon.
Yeah, right.
Instead of embodied carbon. But I thought your conversation was useful to me because you also point out what the difference is. And there is embodied carbon, and it's different from total upfront carbon.
Right. Yeah, I think that the really unfortunate thing about the term embodied carbon is when is so easy for somebody who's new to the term to think that it means carbon sequestration.
Yeah.
And really, so Elizabeth Boudinot just did the 101 episode for Passive House Accelerator Live at the beginning of the month about embodied carbon and how to reduce embodied carbon. And in that conversation, she was often saying embodied carbon emissions, which I thought was helpful to it's still not a perfect term. We're all kind of, I feel a little bit saddled with it, But it's so easy I think for people to forget that embodied carbon is like in some ways we want to have materials that embody carbon inside them and sequester them out of the atmosphere and store them for the life of the building. So that seems like a good thing, but really embodied carbon is about the emissions that were emitted to make that material and to get it to the site and all that. So it's really it's really an unfortunate term.
Well, and we're focusing on the embodied part of that, and of course the other part is that it's not always carbon. It's
right.
Embodied carbon is measured in CO2 equivalent, because that might also be methane or nitrates or all sorts of other things that go into the atmosphere that have a warming effect. But it's useful to put that in equivalent terms so that we've just got this. The literal term is, or the unit of measure is, carbon dioxide equivalence of global warming potential.
Yeah. Good point.
A lot of it is carbon, though, in the products that we're talking about. I really liked Chris's description of a tree and visualizing what happens when you take a tree from a forest and it eventually becomes a stick of wood in a building, and how much of that tree doesn't make it all the way. And I think it's very tempting to think of trees good, timber good, because we're storing all this carbon, and isn't that great? We're planting more trees. It's a bit more complicated than that.
Exactly.
Yeah,
exactly. Yeah, I mean, I think several years ago there was I remember seeing a presentation from a builder in Europe talking about the sequestering potential of trees, and just I think there was a period of time where we got a little bit carried away. Honestly, with that idea that you could lock up a bunch of carbon with wood, because it's missing kind of the systems thinking about, okay, well, what is the ecosystem? What is the harvesting system? How do you the whole manufacturing process to create the boards? All of that kind of, it is more complicated, and it's not clear that wood can sequester any carbon, compared to its natural state.
Well, a couple of things that I thought really important points is that only about half of a tree gets used. We very rarely think about the rootstock, so we're only even cutting down, you're only seeing half the tree to start with. So it's potentially even less than that when you consider all that stuff under the ground. And then all the branches that get stripped off, and then only the parts of the trunk that actually gets eventually turns up as timber. Some of the other material may or may not get reconstituted into other engineered boards, but there's still a lot of that biomass that doesn't end up as useful building material. I thought that I really liked his question that he kind of challenged us to ask all the time is what would happen to this material otherwise?
Mm-hmm.
And that's a really helpful lens to view any material, whether it's from like pine from a plantation, a monoculture plantation forest, versus a decking timber that's come from a tropical hardwood from a rainforest somewhere. Very, very different, and not necessarily good or bad. Better. Both of them have good things and bad things about them. So it's complicated, I think, is the other aspect of that. So we need to ask the questions, and he's also humble enough to acknowledge there are some things that he doesn't know. And I think as an industry, there are questions that we don't know. And I struggle with this quite often. People ask me, what are the best materials? What should I be building my building out of? I had this the other day. I presented a picture, and it was an intertenancy wall with lots and lots of timber in it, and I was pointing out that, in fact, it probably had too much timber, and someone said, well, what's the perfect intertenancy wall? And I said, I don't know, because it depends on so many different factors. And I think that's always a really important thing to be able to acknowledge, is that we don't necessarily know, but we can do better. It's not necessarily a question of head in the sand, it's all too hard. It's just that there might not be the ultimate right answer, but we can progress by doing better than the alternative.
Yeah, well, and you're right that when in a complex situation, then knowing the right answers or right questions to ask really do help guide you through that. And so that question about what would happen if what happens to the material if you don't harvest it, I mean, that can draw you to recognizing that if there are forests like we have all throughout the western part of the U.S. and I assume forest practices have been similar in Canada that need to be thinned in these what they call fire sheds that are like they're just ready to go up in flames with wildfires because there's so many densely packed trees that the answer to that question could be that they are just going to burn. So it's better to harvest those and to actually truly are sequestering that carbon compared to what would be happening to it otherwise. It also drives you then to look at things like straw and the other biomaterials that aren't wood that Chris was bringing up, which I think a lot of that is really exciting. There just seems like there's so much potential there.
It seems huge that the quantities that he was suggesting of potential organic material that is essentially a waste product from agriculture, even if part of that can be used, but just thinking about that from a systems point of view of saying, well, how much of that industry could we be making better use of? Because there's probably other waste streams or current waste streams that we might be able to be making use of. So that's a pretty exciting prospect of integrating our food and agriculture systems with our building material supply industry.
Absolutely. And I think it's not just the building industry that's starting to think in these ways and look for these kinds of opportunities. I was just listening to a great new podcast by Hannah Ritchie, and they just had on that podcast a guest. So the name of the podcast
is this Solving for Climate? Is it
Solving for Climate? It is. It's Solving for Climate. Yeah. Did you listen to? Yeah. So the recent episode was the guy who has a company that is doing bio-based plastics, and so they're looking for similar sources of cellulose, essentially.
Yeah.
And so I think they're probably asking, a lot of the same questions that we're asking when we're thinking about what kinds of biomaterials actually can be part of the solution.
I think our goal for 2025 should be able to get Hannah Ritchie on the show.
Oh my God, I would love to. I tried to get her to do the Reimagine Buildings 24 conference, but she was in the middle of a book tour and I didn't hear back from her. So if anybody who's listening knows Hannah Ritchie, we would love to get connected with her. She's awesome.
Yeah. Well, I think this is going to be an ongoing conversation. I'm telling all the people that I talk to, particularly young people who are getting started in any part of the construction industry, that they have a huge opportunity to get schooled up on carbon, anything that they can. If they can get knowledgeable about that, they'll have a pretty solid career. But that goes for people who have got more experience in the industry as well. This is definitely an emerging conversation because we don't have all the solutions, and that's an opportunity right there. Is people figuring this stuff out and working to do better stuff.
Indeed.
All right, really enjoyed that. I'm going to go and check out more of Chris's work. I'll just give those links again. Check out all his stuff available, chrismagwood.ca. And you can also find the BEAM calculator over at buildersforclimateaction.org. And Zack, you want to do a bit of a plug for the other resources available?
Yes, absolutely. Reimagine? Yeah, absolutely. I'm gonna share some events starting kind of back. I'm gonna go backwards because you mentioned Chris. Chris is going to be doing a Ask Me Anything hour-long session on Friday, December 20th. On the Reimagine Buildings Collective. So members of the collective will be able to hang out with Chris, get to know him, and ask any of your burning questions and just have a conversation with Chris. This is part of a series of Ask Me Anything sessions that we're doing on the collective dedicated to biomaterials and embodied carbon. So this episode is coming out on December 10th, Tuesday, December 10th. We will have just done an Ask Me Anything with Lindsay Love, a builder in Wyoming. And then on December 13th, we'll have an Ask Me Anything session with Jacob Recusen, who is a colleague of Chris's, and Chris and Jacob developed the beam tool. That's one of many hats that Jacob wears. He's incredible. So we'll be doing an Ask Me Anything with him on December 13th. And then on December 17th, we're going to be doing an Ask Me Anything session with Elizabeth Boudinot, who I mentioned earlier. She's an LCA expert and an analyst with a firm called CarbonWise in British Columbia. So really great opportunities to have some more intimate conversations with these thought leaders and leading practitioners. In addition, this week, we have a lot going on at the Passive House Accelerator. On Wednesday, we have a Passive House Accelerator Live Project of the Month episode called Breaking New Ground, Ultra Low Carbon Housing in Vancouver. And then on Thursday, we're going to be joined by 475 High Performance Building Supply for their Component Spotlight, a first look at the new 475 office. So this is going to be a break from the norm in terms of our Component Spotlight presentations. We'll be looking at 475's brand new office, which features a bunch of their products and is a beautiful space. So it's going to be a lot of fun. So, sorry, that's a lot to digest.
There's a lot going on.
The simple version is we have a couple of really great events at the Passive House Accelerator. And if you're a member of the collective over the next couple of weeks, you get to do a bunch of cool, intimate conversations with these great leaders.
Awesome. All right. Make sure you're signed up for newsletters so you're getting all that information because there's a lot of stuff happening. Hopefully keep people busy over the break and lots of all those really great courses as well. Don't forget in Reimagine Buildings Collective. Lots of really good stuff. And we've got some more interviews coming up, Zach. So we'll be back again next week on Passive House Podcast.